So let's go right to it. Today I'll talk about our latest release, CloverDX 5.16, which we released on Tuesday, so 2 days ago. As usually, this is one of our regular releases. We have 4 major releases per year. This is the September one, and the next one will be in December. First, let's talk a little bit about what's new on the highlights, and then I'll talk about different things a little bit more on the a little bit more detail, and I'll show the demo of different features. So the first thing that we've released with this version of Clover is what we call CloverDX Marketplace. This is a high quality collection of libraries that we've created, and you can use these libraries in your projects. I'll show you what it looks like, how you can use those libraries, and what you can do with them. Related to that, we also improved the libraries themselves. So it's now possible to include additional entities in your libraries, like, for example, graphs, job flows, data services, and so on. We have one new component in CloverDX 5.16, a component called HL7 Reader, which allows you to read HL7 version 2 data. Again, I'll show you what it looks like and how it works on the demo. And finally, besides many smaller improvements, we have made available an official RPM repository so that you can very easily install CloverDX on Linux, for example, on Red Hat Enterprise Linux, with practically a single command. After you do some initial repository configuration, it will be very easy for you to install the server. So let's go right to it. The first and the biggest thing that we've released in this release is what we call CloverDX Marketplace. As I mentioned, this is a way for us to share something that we've created over time, because we have a lot of libraries or subgraphs in general that are useful in all kinds of different projects. They typically implement various connectors or frameworks and so on. And we tend to reuse these quite often, so they are well tested, they are supported in a way where we can help you if there are any issues with those. And we know that many of our customers, when they start working with Clover, they either ask how to create something like that because they have similar requirement, or they are asking for something exactly like what we've already created. So we have published all of these in our marketplace. This is a public collection, meaning that you can use everything that's published there for free. You can modify it because the source code of all of that is available. You essentially download a library or a CloverDX project that you can see inside, so you can learn how it works, if it's something interesting to you, or you can modify it to fit your purpose. You don't need any accounts or anything else. So even if you are doing evaluation of the product, you are able to download everything from the marketplace as well. The marketplace is accessible in 2 different ways. The first way, and I'll show you both later, the first way is via web application. This is very useful if you just want to kind of browse and don't want to start the server or anything like that. So you can just see what's in the marketplace, if there's anything new, or read the documentation for different libraries. And then there is a different way that allows you to very quickly install everything that's in the marketplace by connecting directly to the marketplace from your server. This will obviously only work for a server that can access the marketplace location, which currently is in the in Azure blob, but will be very likely publishing additional mirrors, so people who cannot get to Azure blob will be able to use that as well. So when we talk about the marketplace, what's in it? Our goal with that is very simple. As I mentioned, we want to publish as many things as we can, but it of course takes a little bit of time to clean everything up, to add documentation and so on. So we are starting with a collection of 13 libraries for now. You can see what they are in the bottom half of the slide, and I'll talk to them a little bit later when we get to the demo. We'll be adding additional connectors or additional libraries to the marketplace as we go along, right? Oftentimes we create them as part of our exploration of different technologies and so on. So whenever we implement something useful, we'll add it to the marketplace, so we can expect new things to come out of there fairly regularly. Related to the marketplace, and something that helps us get there, are improved CloverDX libraries. If you remember, we released the first version of the libraries feature in Clover 5.14, so about half a year ago. And since then, we've been improving it to allow you to put more things into the libraries. So with the latest release with 5.16, we now allow you to add graphs, job flows, data services, and metadata into your libraries, which means that you can build libraries which are significantly more useful than just, for example, connectors, but you can also use it very effectively for various frameworks. You can imagine, for example, a framework for maintaining a data warehouse or data vault or something similar. And these kinds of frameworks oftentimes require various kind of servicing jobs, for example, jobs that keep track of what data was updated or maybe delete some temporary files and so on. And this is what you can now do with libraries. You can put those graphs, job flows, or even APIs and so on into the library and configure them to run on the server in different ways. For example, schedule those job flows to do something. You can publish data services, so your libraries can serve APIs directly. And I'll show you what it looks like. I have an example that does just that. The same thing is true for metadata. You can now include metadata in your library. This is something that will allow you to share metadata across the organization, because oftentimes we see that, for example, especially in large organizations, people have different ideas what each entity means. Like if you talk with different parts of the organization and ask them what kind of properties a customer entity has, they will give you different answers, very likely. Unless you have some sort of robust governance framework, everyone will have different ideas. And with metadata that you can share through libraries, you can create a customer entity or different versions for different teams and share them with everyone so everyone understands what you mean. You can version everything, so it's very easy to work with it. Additionally, to help you navigate the libraries, especially if you have more of them or if they are more complex, we now allow you to include documentation in the library. So each library can contain a markdown file, which allows you some basic formatting, tables, and so on. And we can render that file either in the marketplace itself. So when you browse through the libraries in the marketplace, you will see the documentation for each, or you can show the documentation in the server. So when you are looking at a library, either before the installation from a repository or from marketplace, or once it's installed, you'll be able to read this documentation directly in the server UI. And again, I'll show you what it looks like when we get to the demo. So these features together allowed us to build more powerful libraries, and these kinds of libraries are then included in our marketplace. Next feature that we added was the ability to work with HL7 data. For those who don't know what HL7 is, it's a healthcare data format. It's a very complex format. It's been created, I think, around 80s, so it's about 40 years old by now. And the files look somewhat like this, at least the version 2 files, right? There are different versions of HL7, and we work with version 2. There are multiple different subversions of that, and they are all text files with very complex layout. There are different entities that you can have in the file, probably hundreds or maybe even thousands of them in total. They have a different number of fields, and this all differs depending on what kind of version of the file you have. So in general, when you need to ingest HL7 data, it can be a pretty complex job to even parse the file and then make sense of what's inside. So with HL7 Reader, we've taken the first step of helping you understand the data, because we now have a very robust component that allows you to parse HL7 data and convert it into variant, meaning that the whole complicated file that you have you can see here gets converted in a nice variant kind of JSON-like structure that you can then process in Clover further. Usually what we see our customers do with this is that they pick the data apart in some way. For example, if you need to load it into a warehouse, you need to turn it into a flat structure, right? So you'll need to pick whichever fields are interesting for you and form entities out of them that are loaded into the table. Or oftentimes we see our customers validating data in HL7 because there are often mistakes in it. And that can be done directly on the variant, or again, you can map it to a slightly different structure. And very common use case is converting to a different layout, often JSON or XML, but not matching the HL7 standard, something custom, something native to whatever the customer is doing. And that is something that you can do once the data is in variant as well. It requires a little bit of coding, but that's something that is kind of expected because these use cases tend to be relatively complex and require heavy automation just to cooperate well within HL7 frameworks and kind of the whole ecosystem. The component is interesting by the fact that it's fully automated. So it will automatically detect HL7 version. It will parse it, parse the file using that version. And it will also work with customized messages. Because what is very common with HL7 is that even though there's a standard for that, there are many different implementations and they not always follow the standard. The standard also allows some customization, so the component can handle that. So it will give you all the data that it can parse, and will also give you nice and readable error messages if there is something that the component cannot handle. So you'll have the ability to decide what to do with the message, whether to reject it in some way or whether you want to keep it and process it further. And again, I'll show you what it looks like and how the component works a little bit later. What's important is that this is an incubation component, so we plan to make improvements to it in the future. For example, we have ideas about a nice mapping user interface for HL7. So instead of converting directly to variant, you'll be able to pick which part of the message you want to handle, similar in a way to what we do with XML or JSON files. And the last large feature that I'll cover today is the official RPM repository for CloverDX Server. This is something that will help every Linux administrator running on Red Hat Enterprise Linux or CentOS, because the packages are aimed at those platforms which are supported by CloverDX Server. And with the RPM repository, you can very easily install Clover. Essentially, this is the only thing that you need to do. Of course, you first need to configure the repository because it's not part of the official Red Hat or CentOS distribution. So you can very easily add our repository to your installation, and then you can install or upgrade Clover with a single command like this. On a basic level, this will install everything you need. So it will install the server, configure it on a basic level. And if you want to evaluate it, for example, you can just start it, right? So if you start the server, right after that, it will run and it will work. It will use Derby as a backend database, which is not recommended for any serious use. It's fine if you want to, for example, try a new feature from new version of Clover, or if you are doing evaluation, but it's not suitable for production because it simply doesn't offer the performance of a real database like PostgreSQL or Oracle or anything else. So for full configuration, you simply configure the server just like you are used to, right? The RPM will install all the elements of the server in specific locations, which are documented in our documentation, and you can then simply configure it just like any other instance of Clover. There's no additional work or anything like that. It looks exactly the same way like if you install it by yourself. And the goal with this RPM repository for us is mainly to help everyone who wants to automate their deployments. This is kind of getting more and more popular, where people are trying to either deploy with Docker, Kubernetes, or directly into virtual machines, and they often need to automate the deployment. So this kind of thing with RPM repository makes that much easier because it can keep track of your versions, and even the upgrades are much simpler than having to deal with everything by yourself. There are, of course, many other changes in this release. I'll list just a few of the interesting ones, and then, as usual, you can see the full release notes with details of everything that we've changed on our website. So the first of the smaller changes that I will not demo today are changes in Salesforce Reader, or in general Salesforce Reader and Writer. We have upgraded the backend SDK for Salesforce, and we can now use select fields syntax in the SOQL statements. This is something that will allow you to query a lot of fields or many fields at once without having to explicitly write their names. It's roughly equivalent to select star that you know from a database, but it does have quite a lot of restrictions. So we expect that Salesforce will continue improving this in a way that will allow us to implement something even more powerful in the future, where we'll be able to offer something similar to SQL query metadata also for Salesforce. So for now, this is the basic version that the API allows, and we'll see what Salesforce does with their API, whether they'll implement something more powerful or not. Bulk components like Salesforce Bulk Reader and Bulk Writer are not affected, right? They are using completely different API, and that has stayed as it was before. Another very useful feature, especially if you are using cluster, is the monitoring of shared file system. On a cluster, this is a very unusual failure mode for a cluster, because typically the file system is not something you expect to not have access to, but still there are some cases where this can happen. So we've implemented a monitoring for the shared file system in similar way like we do for a backend database. So you have multiple nodes in a cluster, And if any of those nodes lose connection to the file system, the node will be automatically suspended and it will not try to run any jobs, because obviously if it cannot access the file system, the jobs will not run because it will not be able to run them. So this kind of node will suspend itself and it will wait. It will retry the file system. Maybe it will come back after a while if there is some sort of network problem or similar. And after that, it will resume itself automatically. If not, it will stay suspended and your cluster will be a little bit smaller by one node, but it will continue functioning without any problems. So this improves the cluster stability and kind of predictability, especially if you are running in some sort of network where you expect frequent failures between different components of the cluster. We've also improved the deployment automation for the server. You can now import master password during server startup. So there's a new configuration property called master password auto import file, which you can configure with the file path or file URL, and it will read your master password from there. Again, this is aimed at customers who are doing deployments in cloud through automation like ARM or CloudFormation, Kubernetes, and similar, where you typically need to configure the whole instance with everything without anyone having to touch it in any way. And the master password configuration was the one thing missing there that was hard to work around without proper API or proper way of doing that. We've also increased defaults for record and field size limit. This is something that will not really affect most of you, but there are some of our customers who, for example, process large files and they send the whole file across the edge. So it's not reading the file record by record, but for some reason the file is read as a blob and transported across the graph. So default limit we had since about 2010 or 11 was 32 megabytes as the maximum size. Now we've increased that to 256. Don't worry though, this is not going to increase your memory usage in Clover 8 times. It has no impact. This is a soft limit and the edges are sized dynamically. So they start with a very small size and they get resized automatically depending on the data volume that you are sending. So this will only affect those customers who were going above this limit. So they will now fit into this one. So they will not have to change it manually. It will be a little bit easier for them to work with those, with that kind of data. But for everyone else who is typically very well below 32 megabytes per record, nothing has changed, and the memory consumption will stay exactly the same. And for those of you who are technically minded, this is an interesting topic about how Clover does that. So we have a documentation page that explains how we allocate memory on the edges so that you can read a little bit about that to see what Clover does to make sure that we keep good performance and don't eat too much memory while doing so. And as usually, we made some changes on the backend, updating platforms, various libraries, and so on. So the biggest of those are support for new application server, OpenLiberty 22. Before we supported OpenLiberty 20, so we no longer support that one. We switched fully to version 22. Both are pretty much the same thing. There are small changes between them. So it should be an easy upgrade for those who are using OpenLiberty. A bigger change is in supporting PostgreSQL 14 as a backend database for CloverDX Server. This you can do in every version of Clover. So whether you are doing on-premise deployments or cloud deployments through our offers from AWS Marketplace and Azure Marketplace. And this is actually where one of the compatibility changes came from, because both AWS and Azure required quite large changes in our template and offers in those marketplaces to be able to support PostgreSQL 14. For example, for Azure, it means that instead of a single server template, we now have to use flexible server. And similarly for AWS, there are larger changes. This means that if you are using those offers to run CloverDX, and if you have any version before 5.16 and want to upgrade to it, you will not be able to do that automatically the way you are used to, right? Normally, you just select the new version, click the upgrade button, wait for a minute or two, and the automation does everything. But these two offers, they cannot be migrated in that way. There are few manual steps involved in that, but they are fairly easy. We have them documented. So in our release notes, you will be able to find the links that go to documentation pages for each platform. And so just have a look at that if you are using the offers. and want to upgrade from previous version of Clover. We also removed one feature called remote persistence. This was a very seldom used feature where you were able to configure a somewhat asymmetric cluster where not all nodes have had access to its backend database. One of those nodes can then serve as a proxy and other nodes would connect through that. This is something that was almost never used, and it didn't have very good performance, as you can imagine, right? Because every access to the backend database was proxied through some other server involving one more hop. So the latency of especially small jobs running on the nodes that were unlucky ones was much lower than what was on the proxy node. So we removed this feature completely. But as I mentioned, this is very unlikely that you've used it. So you probably don't even know that there's something like that in there. And that's everything as far as the tier goes. Let's now have a look at the demo. I'll start with the marketplace. So let's start with that. Let me just get rid of the toolbar from here. So as I mentioned, one of the ways of accessing the marketplace is from the website. The URL is very easy to remember, marketplace.cloverdx.com. And this is what you see. It gives you a list of everything that's in the marketplace. And as I mentioned, we now have 13 libraries there. And for each of them, you can read basic detail over here, or you can directly download that, or click on it and you'll get the documentation. This is the documentation that you can include in your library in that markdown file that I mentioned that we implemented as a new feature for the libraries. Right, so you can see that it's something that's fairly nice. You can add tables. And in case of something like this, where we have a library that implements a set of subgraphs that work with Azure file storage, you can document each subgraph, what it does, what's the parameters, what are the metadata coming out and into the subgraph and so on. Right, so you can give your users quite a lot of information about what's included in the library and what they need to do to get it to work. And since this is part of the library, you will be able to access it anytime, even without having to access to the marketplace, because once you install the library, you can see the same information in the server. So let's actually have a look at the server. This is the second way of accessing the libraries. If you remember, in the previous version of Clover in 5.15, we've included a concept of what's called a repository, which is basically a location that allows you to install or collect your libraries in a single place, and you can install them from there. The main reason for that is that many organizations have a set of libraries that they want to share between multiple different people, multiple different projects, and the repository is some central location they set in-house in their network, whether it's in cloud or on-premise, and they can install from there. So the marketplace itself has its own repository, and you can access it directly from your server. If you are installing new CloverDX Server 5.16, the repository will be pre-configured for you. Right? So this is the one, and if you wait a little bit, it will download the cache of the libraries on the backend when you connect to it, and it will show you all the libraries that you can install from the marketplace. So let's give it a second or two to finish. Seems to be a little bit slow for me today. And in this screen, once it loads, you'll be able to see which libraries you have installed from the marketplace. So you can see I have 4 of them installed, and you can click on each of them to see the documentation, right? It's the same documentation. The layout is slightly different, but it's the same content. And you can also see the technical part of it, which objects are published by the library. For example, the Azure file storage only publishes a set of subgraphs, so you can see which subgraphs they are. And if you want to install something from there, for example, if I wanted to install this one, I just click install in here, it will download, and that's it. I now have a library that I can use. So if I'm working in any project connected to the server, I will be able to use the library from the designer, right? And if I switch to a designer and open, for example, something like this, these are all the libraries that I have. And you can see the Azure file storage library has been added here. It has not been there before, which I haven't shown you, but you just have to trust me on that. And you can see the subgraphs that are here. And if I wanted to do something with those, I can just put them into my graphs or job flows or whatever I need. right? So they behave kind of like a regular components from that point onwards. And again, you can access this kind of documentation at any time. You just need to go to the libraries and click on the library that you are interested in, and it will show you what's inside. As I mentioned, we will be updating the marketplace itself, right? Not only by adding new libraries, but we'll also be implementing improvements to the existing ones. So if you check it from time to time, the interface will show you whether there's something new, right? So if I go to my repository and have a look at that, if a version of a library has changed, I will be able to see that. I, of course, don't have any library that I have changed in here, so it's not going to show me anything new. But for example, if I had Azure File Storage version 1.1, because we've made some improvements, it will appear as a new library in here, and you can install it and use it in one of your projects. And the benefit of that is that you can install multiple different versions of the same library to make sure that you don't have to switch all your projects that are using a library at the same time, because it's not always possible to do that, right? So you can decide whether you want to keep just the latest version, for example, and all your projects will have to switch, or you may keep multiple different versions and do it that way. I mentioned that there are libraries that can include more than just subgraphs. So let's have a look at this one. This is a library. It doesn't have a README file, but it shows you what's inside. This is a library that implements what I call a data tracker. It's a simple set of subgraphs that maintain a database that allow you to submit information about what data you are processing, and it will keep track of that. Like, for example, file arrived at certain time, then something was happening with it, like processing started, errors were found, processing finished, and so on. And this is supported by a set of subgraphs that you are using from jobflows, typically, that allow you to insert events into the backend database. You can clean the database if you want to, throw everything away. But there's also a web application attached to all of that. And this is done by serving it through data services that are part of the library. And there's also some metadata that you might be able to use if you need to. So you can see different kinds of entities in here. And the project for the library like this looks just like a regular one, all right? So I have my data services, my subgraphs, and a graph in here. There's no job flow in there. And that's it. If I want to create it as a library, just like any other library, I can export, and I now have multiple options. In the previous version of Clover, you were only able to select files that are subgraphs. Now you can do more than that, right? It will offer you to select REST APIs or data services, graphs, job flows, or even metadata if you need to. Otherwise, besides that, the library concept still stays the same. It's just a little bit more powerful than what was possible before. And let's have a look at how it works, actually. So I have I'll start with job flow. I have a simple job flow that scans a directory for HL7 files in it. Then it uses one of the subgraphs from the library to track the file, meaning that the data tracker will now know about the file that has arrived into the system. The file is then processed, and after the file is processed, if it's successful, we mark it so, right? So we say, yeah, the file processing was successful. If it does not, we mark it as failed and provide error messages there. There is an user interface attached to that. So let me open that. Oh, actually, sorry, I've closed my tab by mistake. So let's go from data services. I'll be able to see the API that I have there. Oh, actually, I need to go edit this way. And from here. Right, so this is the data tracker web page. It's a separate web application that uses CloverDX APIs published from the library. So there are two APIs that one of them gives you a list of files and the other gives you a list of events that are in the data. And as I mentioned, you can also process or you can also publish other kinds of jobs. So there's, for example, a data app that allows you to reset everything. So if I run it and refresh, all my data will be gone, right? So this is not something you probably want to do on production easily, but still it's very possible to have this kind of servicing job, maybe have a data application that does something and publish all of that from the library. And let's now try to run the example. So as I mentioned, this is a regular job flow, and what's interesting about it are just the violet subgraphs that call the library itself, right? It will find 6 files in my data in directory. Each file gets processed by a single process, which we can have a look at. And that process keeps track of errors, right? So the data is processed, I get my HL7, and I'll show you the meaning of that a little bit later. And I simply track the data that was rejected in this way. And if something was successful, I mark it over here with some basic statistics about that. And if I go back to my application, I see that my files were loaded, right? 6 files, and I can click on each and see, there are a lot of errors in that. This is test data that doesn't really match the standard from HL7. So you can see the robustness of the component. It can capture the records that are invalid and still process everything, and it will give you the data, and it's then up to you to either reject it or decide whether you want to keep it or not. And there will be some that are much better, don't have as many errors. So, and this all is accomplished from a single library. The library tracks the data, maintains the database on the back end, and then serves the APIs that are used by the web application. So it allows you to really build fairly complex processes and workflows that cover everything that you need. So as for the installation of the libraries, there's one more thing that I didn't mention. You can also install manually. So in cases where you cannot connect your server directly to the marketplace, for example, if your server is behind a firewall that doesn't allow that, you can always download the libraries like this, right? You click on it and you get a file with a clip extension. That's a Clover library. It's essentially a zip file with additional metadata inside it. And if you upload that file somewhere to your location or manually to your server, you'll be able to install the library, right? So even if you cannot access the location where the marketplace lives, you'll still be able to install everything from there. All right. And let's now have a look at the HL7 in a little bit more detail. So I'll start with the basic example. It's essentially the same thing that the whole job flow does, except in one graph and with all the tracking removed. So it's much simpler to understand. So let me run it first. And as you can see, there's a single component, HL7 reader. Because it's an incubation component, it lives in an incubation category. We only have one incubation component at this time, so not hard to find. And the component itself is very simple to configure. As I mentioned, it's kind of fully automated, so it will try to do everything by itself without you having to do anything. So you just provide the names of files to process. You can configure the error mapping if you want. The default map by name is easy. You just drag out the edge and it will give you all the information it has. And then you have some options about how you want to validate the data, whether you want to follow the standard 100%, like strictly validate, or whether you want the component to be lenient. At that point, we will try to process everything. It will give you the data, and at the same time, it will report the errors that were found on a separate port. Right? I have it configured to do just that because my files are not according to the standard. And you can see my output from there. Right? Each single file, I've read 6 files. Each single file is converted into a variant. Clover displays it nicely as a JSON, but internally it's represented as an object. So, it's not converting back and forth from text JSON, but rather it's more performant than that. And you can see that the file itself is quite complex, and the files are not large. They're a few kilobytes in size each, but there's a lot of data inside that, and the standard prescribes, the relationship between different entities in there and so on. If you want to handle that, at this point, the best way to do that is to use CTL. And this is why I mentioned that for now we are kind of targeting a more advanced use cases with more complex validations or mapping rules and so on, because CTL is required to process your data. For example, what I'm doing in here is reading everything as a single message, and then from each message, I'm looking if it's If it's this kind of message called ORU R01, which is basically a visit with the doctor with some additional notes, and I'm extracting just those, right? In my case, all files are like that, so I'm keeping all of them. And then from that, I'm just pulling the name of the patient and part of the information from the visit. Some of the visits might have a text attached, something like, if you see the doctor typing a lot of text into the computer, this is what they are doing, right? They are writing details about what should be done next, or what they found out about medication and so on. So what we are doing is essentially combining all the single entities that contain this. There's one entity per line, essentially, into nice text so that it can be, for example, stored in a database later or handled in some other way. Not every visit needs to have something like that, right? There is data in there, but it doesn't store free form text like this, so that part is empty. And if I start from here, you'll see that it's not that hard to work with data like this. The challenge comes from the HL7 itself, where different versions store data in different places. Like, for example, person's last name in version 2.5 is stored like this. In version older than that, it's stored like this. So you typically end up doing a lot of like if-else's to figure out where your data is. And this is something that people who work with HL7 know. It's kind of natural to them, so they can figure it out fairly easily. You can also build automation around this that maps it automatically, that will try different locations for where the data you are looking for is stored. We have done that a couple times before for different customers that we have. So that's something that can save you a significant amount of time, but it's something more complex than what I'd like to show on a webinar like this. And then again, in here, I'm working with the variant, just querying the ORU elements from it and pulling out their value so that I can send it further. If there was any message that doesn't have that, it would be rejected at this step. And so this is what the component gives you. The main challenge with HL7 is parsing the data itself in the first place, and then mapping it into your target is something that for now you'll have to work with CTL. But as I mentioned, this is an incubation component, so we'll be improving that and adding functionality that will allow you to map it much easier.